Hello all, Douse here. Today's lesson, 4.4c, is how power plants work. In order to understand the pros and cons of nuclear science, we need to be able to compare it with the traditional way that power is generated, most often coal. And so to understand that, let's talk about power plants in general. All right, so what are power plants? Well, they're simply used to generate electricity. And they all start with an energy source: fuel, wind, water, light, something that has energy. And then the critical part is that they convert that energy source into electrical energy. And then often that electrical energy that's generated needs to be converted to be a usable form. So it can be transmitted over lines and work in our homes and factories. So we're focusing on this first part just on that conversion from one form of energy to the other. And the first step in that process is often a turbine or turbine. And this is for mechanical designs, which is basically everything other than solar power. The initial energy, whatever it was, is used to spin a turbine. So in the top left, you have the turbine in a hydroelectric plant, and the pipe is where the water would go through. There's kind of a giant fan blade on the inside. Lower left, that's a turbine for a coal or nuclear power plant, something where steam would shoot past those blades and they would spin. And in the lower right, we have wind turbines, where the wind is directly turning essentially a giant fan blade. Regardless of how the turbine gets spun, the next step is a generator. And if we look at the diagram on the lower left, you see there's an axle, which is technically called a rotor, which is hooked up to the turbine. So as the turbine is spinning, that axle is spinning. And in the generator itself, we have a coil of copper wire. So the rotor of the turbine is connected essentially to the coil of copper wire in the generator, and surrounding the coil of wire are stationary magnets. Now, as the coil of wire spins around, the magnets are affecting the magnetic domains in the copper. So the stationary magnets on the outside are affecting the copper atoms on the inside, even though they're not physically touching each other. We know magnetism is a force at a distance. And by shifting the domains around inside the copper atoms, those electrons start to move, and that is usable as electricity. In a thermal power plant design, this is going to be for nuclear and coal. They both basically work the same way. You have a heat source, step number one, that's used to boil water. And that heat source generates steam. Steam goes up to number two, that's the turbine. And you can see that the steam would have to pass through the turbine blades as it goes up and kind of to the right in a clockwise fashion. We see number three, that there's the axle called the rotor that connects the turbine to the generator. So as the turbine spins, the generator also spins. And then step four is all the things that have to happen after that point, where you perhaps convert it into alternating current, you change the voltage, you change the current. So the only difference really between power plants that burn fossil fuels, coal or natural gas or oil, and the nuclear power plants is just how the water gets boiled, essentially what's happening at step one. You'll see in that diagram there, it just says heat. That's pretty generic. If you're going to do a coal boiler, coal is a solid fuel source, and the first step is just to crush it into a powder to make it easier to get mixed in with the air and actually catch on fire. So if you look at the diagram, you have the chunks of coal, and they kind of are being carried on ramps, and they get crushed into a powder. And they get shot, sprayed into the boiler kind of in the middle where the flames are. So they're immediately mixing with the fire, and most of the coal gets burned up as exhaust, and that exhaust will go up the smokestack. And so you can see that there's a really tall smokestack, and there are sometimes things inside the smokestack to make sure it's not super dirty. There's some monitors just to check that too. Pretty regulated, and those emissions go up into the air. Of course, there's also going to be some solid residue with coal, so any solids are going to drop out the bottom. You can see it's kind of funnel shaped. So those solid wastes could also be collected. And this diagram kind of shows us the same thing as we've seen previously. The steam goes up, it will spin the turbine, which is connected to the generator, and here you see there's a transformer and then the transmission lines there. That all is the same. For a nuclear boiler, well, we're just going to use the heat generated from the fission reaction. So uranium is stored in what are called fuel rods, and as the fission reaction occurs, they generate new elements, the daughter nuclei they're called. They generate new neutrons, and they generate heat. And so that heat gets transferred to the water and creates steam, spins the turbine, hooks up to the generator, same basic process as before. Nuclear reactors have what are called control rods, which can be used to slow down the chain reaction so that it doesn't go too fast, generate too much heat, too much electricity. And really the key thing in terms of safety is that there's a containment structure. Any place where the nuclear material is, shown here in kind of the orangish yellow, that's all in really thick concrete structures. The concrete structures are designed so that an airplane could crash into them and they would still maintain their integrity. Pretty crazy. All right, one thing that's often associated with nuclear power plants are cooling towers. You can see the cooling towers in the picture. They're the huge cylinders with what looks like smoke coming out the top. Actually, it's not smoke, it's just water vapor, because the whole point of a cooling tower is to take the steam that had been used to spin the turbine and to cool it back down so that you can reuse the water in the process, not have to continually pipe in new water, which would take a lot. And remember that nuclear and fossil fuel power plants, coal, natural gas, oil, basically work the same way. So just because something has a cooling tower doesn't mean it is a nuclear power plant. And actually, the picture I have right there is a coal power plant. And we can tell that by looking at those big smokestacks there. Those wouldn't be present in a nuclear power plant. All right, I hope this lesson has been helpful for kind of introducing you to how power plants work and the main idea of having some sort of source of energy spin a turbine, having a turbine spin a generator, and that generator making electricity. The big difference in terms of fossil fuels and nuclear is just the heat source in terms of power plant design. But in our next series of lessons, we'll be comparing the other effects of using coal versus using nuclear and the advantages and disadvantages of each. Hope this all makes sense. And hope you're doing well.